All right, so today we're going to talk about what it means to evaluate a function. So you'll remember our conversation about what functions are. Functions are rules that take input values and provide output values with them according to the rule. And so to evaluate a function just means let's just take a function for example here. F of x is equal to 2x plus 4. Okay. So what does this function tell us to do? Well, the name of the function is f, the input is x, and then the output is 2x plus 4. In other words, the output is doubling the input and then adding 4. Okay, so that's how you get from the input to the output. To evaluate a function means to provide a specific output given a specific input. Okay, so for example, if I had asked you what f of 5 is, then what you're going to do is you're going to plug in 5 where the x is. So you're going to do 2 times 5 plus 4, and you should be able to just get a number here. So 2 times 5 is 10, plus 4 is 14. Okay, so f of 5, we would say f of 5 is just 14. Okay, what if we had done f of 3? And I'm going to color code this so you can just kind of see how this works. 2 times 3, that's the input, plus 4. So this would be 10, right? 2 times 3 is 6, plus 4 is 10. So f of 3 is 10. If I plug in 3 for the input, I would get 10 as the output. So to evaluate that, we would say evaluate the function when x is equal to 3. You would say, okay, well, the output would be 10. Okay? Something that's really important to remember when you do this is the order of operations. So many of you have forgotten about this, but order of operations, definitely worth rehashing real quick. Okay, so the order of operations, this may sound blasphemous to some of you, but it is PE and then MDAS. It does not go down like this. It does not go PEMDAS. That is not the order of operations. But some of my teachers showed me that. Yeah, well, it's technically incorrect and misleading. What we do is we do parentheses first, then we do exponents, and then M and D are on the same line. Why is that? Because multiplication and division take the same precedence over each other. We just read them from left to right. So a lot of people, if you've ever seen one of those little things floating around on Instagram or Twitter, or I know you guys are too young to be on Facebook, but people always post stuff, and you might see something like 6 divided by 3 times 2, something like that. And people always freak out. Some people say, well, if you do 6 divided by 3 first, then that would be 2, and then you would multiply by 2. Some people say, well, you have to do 3 times 2 first because multiplication comes before division. So some people do 6 divided by 6 because 3 times 2 is 6. So like this is one way to do it here. This is another way to do it. You get very different answers, right? So this would give you 4, whereas this would give you 1, right? 2 times 2 is 4. 6 divided by 6 is 1. So which one is it? Well, if you see multiplication and division, and there are no parentheses or exponents, you do them at the same time. If you can't do them at the same time, then you read from left to right. Okay, so in this case, we would read, starting from the left, we would do the division first. So this is technically the correct method. This method over here is not correct. Okay, so just remember that. That's really important when you evaluate functions because you may have to do multiple operations. The same applies for addition and subtraction. Addition doesn't necessarily always come before subtraction. We read from left to right. So if you see 6 minus 2 plus 4, you need to do 6 minus 2 first. The minus comes before the plus as you read from left to right. Okay? Just keep that in mind. So please excuse my dear Aunt Sally is how we always were taught the order of operations. Okay, so I'm just going to show you a couple examples. Overall, this is a relatively easy thing to do. So we're going to talk about several different functions. So I may ask you to evaluate a linear function. These are like the best. So if f of x is 3x minus 4, and I ask you to evaluate f of 4, then you're going to do 3 times 4. What you're doing is you're just filling in the x with the 4, right? We know that the function here tells us to take x, the input, triple it, and then subtract 4. We're saying that if this is the input, then we're going to triple it, and then we will subtract 4. Okay, so what is that? 12 minus 4 is 8. Okay, so f of 4 is 8. Okay, so we may ask you to evaluate absolute value functions. Okay, so hopefully you remember absolute value looks kind of like this. So maybe I say f of x is the absolute value of 4x minus 3 or something like that. Okay. The idea with absolute value is that you kind of treat the absolute value bars, I think of these as the bars, as parentheses. And so the idea here is you're going to do what's inside the parentheses first, and then you'll apply the absolute value, and we'll talk about that when we get there. So what if I asked you to find f of 2? What does f of 2 equal? All we're going to do is we're going to say f of 2 is, and let's color code this so that you guys can see this a little easier. I always find the color coding helps. All right, f of 2, so we'll put the 2 in blue there, is equal to the absolute value of 4, here comes the x, that's 2. So 4 times 2 minus 3. And so if we simplify this, we will get the absolute value. We're going to leave the bars alone. The absolute value of 4 times 2 is 8. This may seem a little unnecessary, or as you guys would say, extra, but it's nice to just be very clear on the steps. 8 minus 3 is 5, so we're going to do the absolute value of 5. Okay, and now just a quick reminder on the absolute value. All the absolute value does is it takes a number and makes it positive. If it's already positive, then it's positive, so it doesn't really change it. If the number happens to be negative, then it makes it positive. Okay, and I always thought when I first learned that, I was like, why would you ever have a function for that? But it's actually super useful, and many of your teachers taught you this, that absolute value is technically distance, right? So if this is the number line and this is 0, and I'm at 5, then how far away am I from 0? Well, I'd have to go 5 to the left to get to 0. What if I was at negative 5, right? And then I wanted to know how far am I from 0? Well, that's also 5 units away. Okay, so we developed absolute value because it was really helpful for us to talk about how far something is from something else. Okay, and absolute value, you'll see as you get into like pre-calculus and calculus, it doesn't always have to come from 0. Like maybe I want to know how far something is from the point 3. That would be super useful in physics. Okay, so this right here is just 5 because the absolute value of 5 is 5. Now, if we had gotten a number that was negative, we would take the positive version of it. So let's give you an example of this real quick. I'm going to have to make one up on the spot because I didn't think about this beforehand. What if we do f of negative 1? So we'll do negative 1 here. So f of negative 1 would be the absolute value of 4 times the input, which in our case is negative 1. And then we subtract 3. Okay, so f of negative 1 is going to be the absolute value of, let's do 4 times negative 1. So that's negative 4 minus 3. We're going to take the absolute value of all that. Remember, before you do the absolute value, make sure you simplify everything inside first. So simplify everything inside the absolute value first, then take the absolute value. A lot of people jump the gun here, and they do the absolute value of negative 4, and then they subtract 3 from it. Don't do that, okay? Do negative 4 minus 3, and then take the absolute value. All right, so this will be the absolute value of -4 minus 3 is -7. And the absolute value of -7, well, since it's negative, we make it positive. If you like the idea of asking how far away is it from 0, well, it's pretty clear -7 is 7 units away from 0. It just happens to be to the left. Okay? All right, that's how you evaluate absolute value functions. Now let's talk about quadratic functions. So quadratic functions. All right, so let's say f of x is 3x squared plus 2x minus 1, and I want you to evaluate f of 4. Okay, so f of 4 is going to be 3, and then we're going to put in parentheses here, we're going to put our value in there, 4 squared plus 2 times 4 minus 1. So what I've done here is I've taken the input, and what I'm supposed to do for this function, the rule, and this one's a little more complicated than our linear examples, is to square it, multiply it by 3, then add 2 of it and subtract 1. So what we've done is we've filled in, hey, I would like to know specifically if I put in the input value of 4, what would the output value be? Well, here's the input, and we're just literally following this rule. So all I did was, honestly, I don't even think on these. I just look up at the rule and copy it down. There really shouldn't be a whole lot of thinking when you evaluate a function because you're just plugging in numbers. Okay? All right. So what we're going to do here, and the reason why I wanted to talk about this example, is we need to talk about the order of operations. Some people do 3 times 4, and then they square it. Some people do 4 squared, and then they multiply by 3. Which one's correct? Well, remember the order. So it's parentheses, then exponents, then multiplication and division, reading left to right, then addition, subtraction, reading left to right. So in our case, do we have parentheses? Yes, I guess technically we have parentheses here, but there's nothing we need to do inside the parentheses. It's not like we're adding or subtracting or multiplying or anything inside. So we don't have to worry about parentheses. So the parentheses are good to go. How about exponents? Yes, we do have exponents, so we need to do that first. So what we're going to do is we're going to leave the 3 there, and we're going to do 4 squared. 4 squared is just 4 times 4, so that's 16. Okay, well, let's keep moving here. We could just do this one thing at a time, but let's do multiple steps here on the same problem. 2 times 4 is 8, and then minus 1. And then from here, this is just simplifying, right? We're just figuring out what the rest of the numbers are. Okay, so 3 times 16 is 48 plus 8 minus 1. And then order of operations tells us to do, there's technically addition and subtraction here on the same line, so we're going to do the addition first. So 48 plus 8 is 56. And then the minus 1, so we'll get 55 here for this. So if you happened to graph this function, it would look probably something like this. It would look like a parabola. They look like U's. And if you went over to 4 on the x-axis, I'm just making something up, but let's say we went over and 4 was like right here, and you went up, what would happen is that this point right here would have a y value of 55. Okay, so just want to keep talking about the multiple representations we have for functions. All right, so that's a quadratic. There's one more I want to talk about, and that is piecewise. Piecewise functions are kind of weird. They're new. They actually make a lot of sense, and they're tremendously useful. So a piecewise function is where we have a function like this. And what may happen is you may have dots here, like a colon in front or a colon behind the equal sign. And then you're going to have these weird curly brackets that I'm not the best at drawing, but I'm trying. And what's going to happen here is we're going to have 2 separate functions here, but we're going to still call overall this function, we're going to call it f of x. So what's going to happen here is we might have something like 3x minus 1, and this is if x is greater than or equal to 2. So what happens here is you have a machine that takes an input, and then the machine actually checks what the input is before it decides what to do with the input. Normally on our functions before, it was just real simple. It was like double it and subtract 1. And so we would double the input number and subtract 1. But what happens here is this machine actually has a little bit of discretion and looks at the input and decide what it wants to do. Okay, so what's going to happen here is we have the top version, and then maybe I'll have a bottom version of 2x plus 3. And I'm going to do this if x happens to be less than 2. So what happens here is if I get a value that's greater than or equal to 2, I'm going to triple it and subtract 1. If I get a value of x, like an input value that's less than 2, I'm going to double that number and add 3. So when we ask you to evaluate, say, hey, what is f of 3? You can't just come over here and double it and add 3. You have to actually look and say, okay, which are we going to be dealing with here? Are we going to be dealing with the top version or the bottom version? Sometimes piecewise functions have 3 or 4 versions. Like we could put another one in here and say, oh, hey, by the way, if x is greater than 12 but less than 30, use this function, 3x plus 7. Okay, so sometimes you might have piecewise functions with 3, 4, or more iterations, but we'll just use 2 here for simplicity's sake. So what is f of 3? So we're going to have to come up, first of all, and decide which one we want to use. Since 3 happens to be greater than or equal to 2, because, 3 is more than 2, we're going to use the 3x minus 1 function, but we're not going to put in x, we're going to put in 3, because that's what the input is, and then we'll subtract 1. So f of 3 in this case would be 3 times 3 is 9, minus 1 is 8. So f of 3 is 8. What is f of 1.5? We'll just do a decimal, just to make things difficult. So f of 1.5 means I'm going to have to use this function right here, which means I'm going to double that number and add 3. So we're going to do double that number, so 2 times 1.5. And then we're going to add 3 to that. So 2 times 1.5 is 3, and then if you add 3 to that, you get 6. So f of 3 is 8, and f of 1.5 is 6. If I had asked for f of 0, then I would use this function. A lot of people ask, what if you get asked specifically for exactly f of 2, right? So if we get f of exactly 2, what would we do? Well, what does it say? This says if x is greater than or equal to 2, then you would use this one. Okay, so this is only numbers that are strictly less than 2. We say that word strictly to mean, hey, it has to be less than 2. It can't actually equal 2. This is greater than or equal to 2. Okay, so f of 2 would be 3 times the input, which is 2. And then you subtract 1. So this will be 3 times 2 is 6, minus 1 is 5. So f of 2 is 5. That's how you evaluate piecewise functions. Okay? I want to talk about what I'm going to call abstract cases. And this is where it gets a little tricky. So what if I told you that we had a function, and it was f of x is equal to 3x squared minus 4 over 2x. Okay, so that's our function. It's a little complicated. It's a fraction. It's got some subtraction in it. It's got multiple x's. And what if I asked you for f of 5? You'd say, well, I would just plug 5 in, right? So if I asked you for f of 5, that would be 3 times 5 squared minus 4 over 2x. That, not 2x, sorry, that's wrong. It should be 2 times, not x, but 5, because I specifically want to know if I put in 5 for the input, what I would get. And let's see, I'm just curious numerically what this would be. 3 times 5 squared, so you would do 5 squared first. That's 25 times 3 is 75 minus 4 over 10. So this would be 71 over 10, which is 7.1. if you're a decimal person. Okay? So that's f of 5. What if I asked you something goofy like, what is f of blue triangle? And you're like, well, how am I supposed to know what the output would be if I put in a blue triangle, right? And the answer is, well, just follow the rule. What does the rule say? It says take the input. You got to think of the thing that's in here as an input. Don't think of it as just like a letter or a number or something like that. You really have to think on the abstract level of, I get inputs and I provide outputs. My inputs might be numbers. They might be, ingredients for cooking. They might be a time of the day. It could be a piece of technology. It could be anything. You can put anything in for an input. And the question is, what do you get for the output? This function right here tells us the rule. It says if you have an input of x, go ahead and square that, multiply it by 3, subtract 4, and then divide by 2 of that input. Now, blue triangle is not really a number, so we have a hard time, I don't know, what is a blue triangle? Is it 12? Is it 4.7? It doesn't matter. Just follow the rule. What does the rule say? It says do 3 times the input, which is a blue triangle, squared, subtract 4, and divide by 2 times the input. What's the input? Blue triangle. We don't know what blue triangle is. It's not really a number, but that's okay. We're fine with this. This is it. This is your answer. So if I ask you for f of blue triangle, say that. That's correct, okay? The reason I'm bringing this up is because people do really well in general evaluating functions, right? They have no problem. Like f of 5. If I had asked you for f of 4.7, you all would go in and you'd do 4.7 squared, multiply it by 3, subtract 4, and then divide by 2 times 4.7, whatever that is. You would get a number. That's great. What really throws people off on this is when we ask them to do something like, what is f of 4n? And then people lose their minds. They're like, 4n, what am I supposed to do? I don't know how to do that. To which I say, sure you do. Look at the rule. I'm not even going to scroll all the way back up. Here's the rule. It's right here. Just use this. The rule has a blue triangle instead of an X. So what's the rule? You do 3 times the input squared, where the input in this case is 4n. You subtract 4, and then you divide by double the input, which in our case is 4n. So don't freak out. If I had asked you what f of 8a plus 7 is, we'll do that in just a sec, okay? So don't freak out, but let's finish this one. So f of 4n is going to be 3 times 4n squared. So what we're going to have here is, I'm going to go one step at a time. What is 4n squared? What is 4n times itself? Well, we don't know what n is, but that's okay, because we know that 4 times 4 is 16, and n times n is n squared. So this is just going to be 16n squared minus 4 over, let's see, 2 times 4n on the bottom there. That's just 8n. Okay, and let's just finish this up. So 3 times 16n squared is 48n squared minus 4 over 8n. Some teachers will have you simplify this. If you look closely, each of these numbers is even, so you can divide by 2. In fact, if you want to go quicker, you can actually divide everything by 4, which is what I'm going to do for the sake of time. If you divide everything by 4, you would get 12n squared minus 1 over 2n. Okay? So at the end of the day, f of 4n, whatever 4n happens to be, can actually be simplified down to 12n squared minus 1 over 2n. If you are a computer programmer and you'd like to know, hey, if I put in 4 of something, how can I express that in a very quick, easy way that the computer can just re-spit out a number for me? This is very helpful. Okay, so how about this really ugly example of f of 8a plus 7? Okay, let's actually recolor it here so we can get a feel for it. So f of, let's get a new color here. Let's get something crazy here. Let's do like a pink color. All right. So f of 8a plus 7. So what would you do? just follow the rule. You have the rule. It's right here. People freak out about this. You don't have to freak out. The rule says your input's here. You're going to square it, triple it, subtract 4, and then divide by 2 of that input. Okay, let's do it. So we're going to triple the input squared. So we're going to do 8a plus 7 squared minus 4 over 2 times the input, which in our case is 8a plus 7. Okay. I'm going to save the time and energy of actually going through and squaring that, because that's not the whole point of this. I just want to say that this is how you set these up. And if you feel comfortable doing distribution and doing 8a plus 7 squared, like using the FOIL method, some people use that, then you're good to go. You would know how to do this and you'd be able to simplify it. Okay? So another thing I want to focus on here is evaluating functions if they're given to you in table form. So you might be asked, hey, what is f of 2? And we've already gone over this. So f of 2, you would just look over, these are the inputs, and then the question is, what's the output value when the input value is 2? So just look at 2. The output value that goes with it is 3. This is fairly simple and straightforward. F of 6 would just be 2, because if you look at the input value of 6, the output value that's paired with it is 2. What gets a little tricky and what kind of trips people up sometimes is I may say f of x is 4. What is x? And a lot of people might say 5 because they're like, well, here's 4. 5 is paired with it. But be careful. It's saying that f of x is 4. Remember, 4 is the output value. So 4 is the output value. The question is, what was the input value that gave you 4 as the output value? So just be really careful here. X in this case would be 7. 7 was the initial input value that provides an output value of 4. All right, so the last thing I want to talk about here is if you're given a graph, and yeah, I know there's a lot of questions here. What do we do with things like f of negative 4, right? We don't have a table, we don't have a rule, we have to rely just on the graph visually. Okay, so let's go through each one of these. We'll take them one at a time here. So the first one is, what is f of negative 4? And all it's asking is, if you put in the input, and remember, this is the x-axis, these are the inputs, and this is the y-axis, these are the outputs. If you put in negative 4, what do you get out? Okay, so f of negative 4, we'll put our answers in green here. F of negative 4, so if we go over to our graph and we look at it, it goes along here like this, then down, then up again. If you go over to negative 4 for the input, that's right here. Okay, so we are looking, when x is negative 4, what's the y value that corresponds with it? It's right here. Okay, so f of negative 4 is just going to be 3, because the y value that corresponds there is 3. Okay. 2 is asking, find x if f of x is negative 3. So be careful. This is not asking if x is negative 3. So we're not going to look here. This is when x is negative 3. It's saying the output value is negative 3. So you want to come down to 1 to negative 3 right here. And the question is, what is the input value that provides an output value of negative 3? And this is kind of a trick question because there are 2 of them. Okay, so there's one clearly labeled here, but there's also one that's not labeled here, but it looks to me, if it doesn't go right through negative 7 there, it's really close. Okay, so there sometimes are multiple answers here, which is a little weird. Okay, so find x if f of x is equal to negative 3. We will say that x equals either positive 2 right here, or x equals negative 7. It looks to me like it's negative 7. Even if they don't give you a point, sometimes, it looks like negative 7 to me. Okay. All right. Number 3, how many values of x are there for which f of x is equal to 1? Okay. So all this is asking is, hey, I want you to consider the output value of 1, which would be right here. How many input values are there where the output value is exactly 1? Okay, it's not asking you to give those numbers. It's just asking how many there are. And I'm going to say, just visually looking at this, that there's 1, 2, 3. I don't know exactly what they are. This is probably like negative 5.8 or something like that. But it's not asking what they are. It just says how many values of x, in other words, how many input values are there for which the output value is 1. So we'll just say, hey, there are 3. And we'll actually write that. There are 3. Okay, number 4, how many values are there for which f of x is equal to negative 2? How many values are there for which f of x is equal to negative 2? And it's asking, it's kind of implied here, but it doesn't say how many x values are there for which f of x is equal to negative 2. So let's look. Where is f of x negative 2? So you can, sometimes what I imagine is just, I kind of imagine a line here. I'm trying to pick a good color for this. I try to imagine a line when the output value is negative 2. So if you imagine a line going across here, anywhere where that function, this green function, crosses that blue line, we have a point. So there's one specifically here, there's another one here, and there's another one here. Again, I'm not exactly sure what the x values are that match with those. Like this one would be probably about right there. This one is probably about right there. And then this last one is probably about right here. I don't know exactly what they are, but it's not asking what they are. It's just asking how many there are. So again, we'll just say, hey, we're not sure what they are, but we'll say there are 3. And the last question here, how many values are there for which f of x equals negative 4? Okay, so we'll do the exact same thing we just did. How many values are there where f of x is negative 4? So I'm going to erase what we just looked at, or what we just drew. Negative 4. So if you come down to negative 4, that's kind of like this line right here. And if you look, I'm only seeing 1. Okay, so we'll say there is, oh, I need green. There is 1.